Testing, testing. 1, 2, 3. All right. Hi. I'm not dead. Close to it. I'll be back tomorrow. So, anyways, number 1, match the function to the graph. So this has a vertex of positive 2, comma 3. And since there's a negative in front, that means that it needs to be going downwards. So the only function going downwards is c. This has a vertex of 2, comma negative 3. Remember, opposite of what's on the inside, same as the outside. And that only one would be b. And this one has a vertex of negative 2, comma negative 3, which has to be graph A. Okay, down here, what's the equation for the axis of symmetry? Start off with the vertex. The vertex is at negative 4, comma negative 2. And remember, the axis of symmetry is the line that cuts it in half. So like for this graph right here, it'd be the equation of this line, which is just x equals whatever the vertex is. So in this case, since our x value is negative 4, our answer is D. Did I? Okay, that's still here. Okay, moving on. Alright, so what is the maximum value of k of x? The maximum value is right here at the vertex, which is at 0, comma 3. So therefore, the maximum value is 3. The axis of symmetry blah, 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 is the x value. So x equals 0. It's increasing on the left side of the vertex. So this is where x is less than 0. And then it's decreasing on the right side of the vertex when x is greater than 0. For number 9, so this has a vertex of 0, comma 0. This one has a vertex of 4, comma negative 2. So that means our x value moved right 4, and our y value moved down 2. So right 4 would be a plus 4. Down 2 would be a minus 2. Your answer is B. And here's how you determine if it's a 0. There's 2 ways to do this. The first way is you could just plug it in. So you just plug in negative 7 squared plus 4 times negative 7 minus 21. And that comes out to 49 minus 28 minus 21, which equals 0. So therefore, 10, or number 10, negative 7 is a 0. You can do the same thing with the rest of them, just plug them in and see if you get 0. The other way to do this is, since this is in standard form, you could factor it. The first two things need to multiply to be x squared, so that's x and x. The last two need to multiply to be a negative 21, so that'll be a 7 and a 3. And since the middle term right here is positive, that means the bigger number must be positive. So therefore, when you set them both equal to 0, x plus 7 equals 0, and x minus 3 equals 0, you get that your zeros are negative 7 and positive 3. So these two are zeros, 11 and 13 are not zeros. And again, you can just plug them into the function and see for yourself. Next problem. The height of the baseball is modeled by this equation. Find the time it takes the basketball to reach its highest point. So this equation is in vertex form, and it tells you the vertex is 3, 68. Your vertex is where the maximum happens, so your answer is just 3 seconds. The annual profit function P for a company selling X items is given by this function. Actually, X that. Where P of X is in thousands of dollars, what is the maximum profit that this company can expect in 1 year? So the vertex, again, you just look at these values. The vertex is at 16, 400. And therefore, the maximum profit is just 400. $400,000. Okay, you have to be careful because it says P of X is in thousands of dollars. Okay, 16. Let me scroll down a little bit just to get a better kind of read on the situation. Okay, for 16, graph this function. So 2 ways you could graph it. First off, start off with the vertex. The vertex is going to be at -1, -3. So -1, -3 is our vertex. Okay, so -1, -3. Let's go ahead and put a vertex down right here. Okay. So again, this is my x value, this is my y value. Pick two numbers on either side of -1 and just plug them into the function. So for the first one, I'm going to do the work maybe over here. This is 2 times 1 plus 1 squared minus 3. Parentheses first is 2. 2 squared is 4. 4 times 2 is 8. 8 minus 3 is 5. So that's 1, 5. And then you can plug in 0. 0 plus 1 is 1. 1 squared is 1. 2 times 1 is 2. And 2 minus 3 is -1. And since the parabola is symmetric about its vertex, those are your table of values. So you go 0, -1. Let me do something like this. And you also got 1, -2, -1. -1, 2, 3, 1, 2, 3, 4, 5. 0, -1. And 1, 5. Okay, and then just connect them all. The other way you could do this is using the 1, 3, 5 pattern. Okay, if you take the 1, 3, 5 pattern and you multiply it by the a value, that's the number in front of the parentheses, 2, you end up with a 2, 6, 10 pattern. So from your vertex, you just go right 1, up 1, 2. Then right 1, up 1, 2, 3, 4, 5, 6. And you just do the same thing on the other side. And that gives you the other points of your parabola. So you can do either way to graph your parabola, it doesn't matter to me. The domain of a function is all real numbers, unless it's a real life function. The range is all real numbers. Since it's a positive function, you can tell because the a value is a positive number. It's going to be greater than or equal to the y value of your vertex, -3. And the axis of symmetry is just the x value of our vertex, -1. This one, x squared. So let's plug numbers in. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And 3 of the first is 3. 3 squared is 9. It's 27, 81. And this would probably make more sense if I did all these problems on the same kind of page. So let's do that. So again, this is 1, 4, 9, 16. And this was 3, 9, 27. That's a 9. And 81. So find the average rate of change from 1 to 4. So this is x1, x2, which means this is my y1 and this is my y2. So average rate of change is the slope formula. Slope is y2 minus y1 all over x2 minus x1. So y2 is 16, minus y1 is 1, x2 is 4, x1 is 1. That makes 15 divided by 3, which is 5. The average rate of change is 5. For this, you're going to do the same thing. You've got x1, x2, but now your y1 and your y2 are different. So it's 81 minus 3 all over 4 minus 1, which comes out to 78 divided by 3 for a grand total of 26. So the rate of changes are different, definitely. What does that mean? That means that g of x is much steeper between x equals 1 and x equals 4. That's all you got to know. Okay, I guess we'll just do a couple of these. Alright, so we need to factor this problem 5x squared, 13x, negative 6. The first two need to multiply to be 5x squared. So this is a 5x, and this is just a 1x. Positive 1 and a positive 5. Okay, next, in the last part, we need two numbers that multiply to 6. So let's try 2 and 3. Let's go 2 and 3. Again, I'm just guessing. Okay, so multiply these two together. 2 times 1 is 2x. 5 times 3 is 15. And this could be a positive 13x if that was negative and this was positive. So therefore, this is a negative 2 and this is a positive 3. So those are our correct answers. I'm actually surprised I guessed it on my first try. I didn't think I'd be able to. Okay, and just to double check, negative 2 times positive 3 does equal negative 6. Okay, find the zeros by any method. So you can either do PEMDAS backwards, or factor. Excuse me, still trying to get over this illness. Alright, so first thing we got to do is add 30 to both sides. So we get 5x squared is equal to 30. Then we divide both sides by 5. And we get x squared is equal to 6. And then we square root both sides to get x equals plus or minus the square root of 6. Remember, when you take a square root, you always end up with two answers. One of them is positive, one of them is negative. For 20, same thing. We're going to subtract 12 from both sides. So we get negative 2 times x minus 5 squared is equal to negative 12. Then we're going to divide both sides by negative 2 to get x minus 5 squared is equal to 6. Square root both sides to get x minus 5 equals plus or minus the square root of 6. Then we need to add 5 to both sides. to get as a final answer x equals positive 5 plus or minus the square root of 6. Okay. For this one, we add 16 to both sides. And we get x plus 2 squared equals 16. Typically, we would divide here, but we don't need to because there's no number in front of the parentheses. Like there's no, the a value is 1. So then we're going to square root both sides. And we get x plus 2 is equal to positive 4. And x plus 2 is equal to negative 4. Now, when I gave your answers for 19 and 20, I actually gave you guys 2 answers. Okay, this is a positive answer and a negative answer. Your answer is both a positive root 6 and negative root 6. You also could write this as x equals root 6 and, negative root 6. You could also write it that way. We just shorten it up a little bit. So you should get 2 answers. We subtract 2 from both sides to get x equals 2. Subtract 2 from both sides to get x equals negative 6. And those are our 2 answers for number 21. Alright, 22. We need to factor this thing. So in the front, 2 numbers that multiply to be x squared, x and x. Now I need 2 numbers that multiply to 60 and have negative 7 somehow. Let's put the factors of 60 down. We have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Those are all the ways that you could possibly multiply to get 60. And it looks like 5 and 12, our combination of them is going to be our answer. So we're going to have a 5 and a 12. 5 times x is 5x. X times 12 is 12x. And we need this to be a negative 7, so this will be a positive 5x and a negative 12. So it should be x plus 5, x minus 12. So then we have to set each of them equal to 0. So we have x plus 5 equals 0. When you solve that, you get x equals negative 5. You also get x minus 12 equals 0. And when you solve that, you get x equals positive 12. So x equals negative 5 and positive 12 for our answers. Okay. For 23, PEMDAS backwards. First step, subtract both sides. 24. So you get negative 24 is equal to x minus 7 squared. Our next step would typically be divide, but there's just a 1 in front, so we don't even have to worry about that. When you divide by 1, you get the same thing. Square root both sides, and you get a little bit of a problem. You can't square root a negative. Therefore, your answer is no real solution. For this one over here, you need to add 10 to both sides. So x minus 3 squared is equal to 10. Square root both sides, and you get x minus 3 equals to positive root 10. And x minus 3 equals negative root 10. I could make this faster by using the plus minus symbol, but I want you guys to understand that they're 2 separate answers. When you add 3 to both sides, you get x equals 3 plus root 10. Add 3 to both sides, and you get x equals 3 minus root 10. So these are our two separate answers. You could condense them to make this x equals 3 plus or minus the square root of 10 if you wanted to make your answer a little bit more compact. But again, this is two separate answers. Okay, you got to know that. All right, moving on. Okay, factor and sketch. So we factor this, and we get x in the front. The back two need to multiply to be 8, so I'm thinking it's going to be 4 and 2. 4 times x is 4x. X times 2 is 2x. And it needs to be positive, so that's a positive 4 and a negative 2. So positive 4, negative 2. So therefore, our intercepts are negative 4, 0, and 2, 0. Let's go ahead and plot those points right now. 2, 3, 4, and 2, 0. Okay. So remember, the vertex, or the x value of the axis of symmetry, is always between the two intercepts, right in the middle. So therefore, negative 4 plus 2 divided by 2 comes out to negative 1. Negative 1 is the x value of our vertex. So the x value of the axis of symmetry, x equals negative 1. So our vertex is negative 1, comma, something. You can find this value two ways. You can either A, plug it into the original function here, or B, plug it into the factored form here. If you do the original function, it's negative 1 squared plus 2 times negative 1 minus 8, which is 1 minus 2 minus 8 for a negative 9. Or, if you plug it into the factored form, this is negative 1 plus 4 times negative 1 minus 2, which is 3 times negative 3, which comes out to negative 9. You do whichever way you like better. But there's your vertex. Oh man, I'm going to have to lay down after this. This graph represents f of x and the table that shows two values. Okay, so this is the f of x function right here. It's drawn on your graph. And this is the g of x function. So this is the minimum value of f of x. That's the smallest value of f of x. That is right there. The smallest value is negative 1. Okay. This next part of the problem says is greater than. So you need to write greater than the minimum value of g of x. So let's look at g of x. The smallest value of g of x is negative 6. So you put negative 6. Negative 1 is greater than negative 6, so this is a true statement. Okay. So this next part, this says the value of x when f of x is at its minimum. So now I'm not talking about the minimum value. I'm talking about the x value of the vertex. Again, still looking at that same point right there. The x value is negative 4. Next part says is less than, so you need to write less than, the value of x when g of x is at its minimum. Again, here's the vertex right here of g of x, and that number is a 3. Negative 4 is less than 3, so that is true. Next one, both x-intercepts. Remember, an x-intercept is where the y value equals 0. I'm actually going to overdo this real quick. Okay. So where y is equal to 0, it doesn't have in this row right here, there are no zeros. But we do know that 0 is between 3 and negative 2. 0 somewhere in there. And 0 is between negative 2 and 3. It's somewhere in there as well. Okay. So they want to know, do they occur when x is greater than 0? So x is greater than 0. Like this is 0 right here. Everywhere on this side. And that's where our x-intercepts are. So that's true. And this says the line of symmetry for f of x is x equals 1. That is false. It should be x equals negative 4. Because again, that is the x value of our vertex. Okay. 27. Okay, rocket's height. The maximum height of the rocket is 2 feet. That's false. The maximum is at the vertex, which is 36. So that's false. That's true. It took 2 seconds for the rocket to reach the ground. After 2 seconds, it's at 0. The height is 0, which means it's on the ground. The domain of the rocket is everywhere between 0 and 2. That is true. And the range of the rocket is everywhere between 0 and 36. True. All right, match the table to its appropriate model. So this has a difference of 3 plus 3 plus 3 plus 3. This answer is A. This has a difference of 5, 3, 1, 1. Actually, 9 minus 14 is negative 5. 6 minus 9 is negative 3. 5 minus 6 is negative 1. 6 minus 5 is positive 1. So therefore, they all have a difference of 2. Since the second differences are all equal, this is a quadratic function. And you can kind of tell by the 1, 3, 5 pattern. Next, this is a times 2, times 2, times 2, times 2, which means it's exponential. And this last one, that's a 6, 10, 14, 18, and each of those have a difference of 4. Since your second differences are all equal, that means this must be quadratic. Okay, for the last problem, look at the scatter plot. Which of the equations would be the best model? Okay, so let's look at this right here. This is quadratic. It is not a line. So right away, you should cross out A and you should cross out D because that's an exponential function. The next thing that you'll notice is that it's going up, which means it should be positive. This is a negative quadratic function, so your only answer is C. All right, that's it, guys. See you tomorrow. We'll go over a lot of stuff before we start our test. Have a great day.